Dear students, under the topic vector differentiation, here we are going to learn a very important result. That is, curl of a vector is equal to gradient of the divergence of a vector minus Laplacian of a vector. So, this result can also be written as where nebula square is the Laplacian differential operator and nebula is the gradient operator. And we know that nebula cross A vector is curl of A, and since we have nebula cross A vector, we can write it as curl of A vector, and that we have to prove that it is equal to gradient of divergence of a vector. Since we know that nebula dot a vector is the divergence of a vector minus nebula square is the Laplacian differential operator, and so Laplacian of a vector. So now in order to prove this result, first we shall consider the left hand side and we shall apply the curl operator on a vector, and we shall prove that it is equal to the right hand side. So for that, first of all, we shall consider whatever is in the bracket in the left hand side. That is, we have nebula cross A vector. So what is this A vector? A vector can be taken as A vector is a vector point function which can be taken as A1 I vector plus A2 j vector plus A3 k vector. Now as the first step, we shall find nebula cross A vector, that is the curl of A vector. We know that nebula cross A vector is given by determinant of, it is equal to the determinant of I vector, j vector, k vector, and then dou by dou x, dou by dou y, and dou by dou z. And here we will be having the ith component which is a1, here jth component which is a2, and here kth component which is a3. So this gives us nebula cross a vector. Now we shall find nebula cross of nebula cross a vector, that is the left hand side of the result. So what will be that? Nebula cross, and before that we shall just simplify this also. We know that the value of this determinant is equal to I vector multiplied with, what do we have, dou y by dou y of a3, and then dou by dou z of a2. So dou a3 by dou y minus dou a2 by dou z. Similarly, j vector, so minus j vector, so it will be, you have to block this column and block this row, so it will be dou by dou x of a3, so dou a3 by dou x minus dou a1 by dou z, so dou a1 by dou z. In a similar way, we have to write for k vector, so plus k vector, so block this column, block this row, so this into this, so dou a2 by dou x minus dou a1 by dou y. So we have obtained nebula cross a vector. And now I want to keep this as a positive quantity. So if I want to make here positive, I can multiply this negative sign within the bracket, and this can be rewritten as dou a1 by dou z minus dou a3 by dou x, and here it will become positive in that case. So I am just making that change and I am going to write. So nebula cross a vector will be equal to, as it is this I vector will be there, and we will have dou a3 by dou y minus dou a2 by dou z, and then this minus I want to make it plus, so plus j vector multiplied with, since I have written here plus, when this minus gets multiplied this becomes plus because you have a minus over here, minus into minus will become plus, and we will get dou a1 by dou z minus dou a3 by dou x, and then for k vector it will be the same, that is k vector multiplied with this quantity. So dou a2 by dou x minus dou a1 by dou y. Now these become the components of I vector, j vector and k vector. Having these components, now we are going to find nebula cross of a vector. So when we take that, these components, these becomes the ith, jth and kth component, and we shall substitute in the determinant at the place of ith component, jth component and kth component. So now we are going to find nebula cross of a vector, which will be equal to, now we have to write the determinant. So first I vector, and then we will be having dou by dou x. And what is the ith component of nebula cross a vector? Here we have the ith component is dou a3 by dou y minus dou a2 by dou z. So that we have to write. So dou a3 by dou y minus dou a2 by dou z. In a similar manner, j vector dou by dou y, and what is the jth component that we have here? It is dou a1 by dou z minus dou a3 by dou x. So that we have to write. So dou a1 by dou z minus dou a3 by dou x, and finally the kth component, and that will be dou by dou z of, what is the kth component? Dou a2 by dou x minus dou a1 by dou y. So that we have to write. So dou a2 by dou x minus dou a1 by dou y. So this gives us the determinant. So this is the, we have to find the determinant of this quantity in order to find nebula cross of a vector. So what will be the determinant of this matrix? This will be equal to first I vector multiplied with, so it will be dou by dou y of this quantity. So dou by dou y of dou a2 by dou x minus dou a1 by dou y, then minus this. So dou by dou z of this quantity. So dou a1 by dou z minus dou a3 by dou x. So for ith component we have done. Similarly j. So here it will be minus j. So minus j vector multiplied with, so we have to block this row and this column. So it will be dou by dou x of this quantity. So dou by dou x of dou a2 by dou x minus dou a1 by dou y, then minus this dou by dou z of this quantity, that is dou a3 by dou y minus dou a2 by dou z. Now for kth component we have to do. So plus k vector, next will be plus k vector multiplied with, now here we have to block this column and this row, and so first it will be dou by dou x of this quantity. So let us write that dou by dou x of, so this one, so dou a1 by dou z minus dou a3 by dou x, and then minus this one. So dou by dou y of this quantity. So we will write that dou by dou y of dou a3 by dou y minus dou a2 by dou z. So this is the determinant value. So in the next step, I want to write this negative as positive. I want to make this positive, which means I have to multiply this negative sign within the bracket. In that case, this term will become negative and this term will become positive, because minus into minus will become plus, and when this minus is taken to this term, it becomes negative. So next step, I am going to write as it is just with the change that here I'm going to make positive and I'm multiplying the negative sign inside, so that this term becomes positive, and I will write in the front first, and then minus this term I will write. So I have done that for you, and this is what we get. So after changing, this is what we get. So in this, you can write, in fact, write even one term, and you can write the summation in general, where you will be changing in the second and the third term in this manner. That is, I will be changed to j. Wherever you have j in the second one, there you have to change as k. Also, you have to change x as y and y as z and z as x again. And wherever you have a1, it will be changed as a2, and a2 will be changed as a3, and a3 will be changed as a1. So in the cyclic pattern, also you can generally write one summation, and you can also show that. But for your more better understanding, I have done all the three terms individually, and I will be doing like that only in while proceeding this result. So anyway, now after making this positive, the terms are shifted, and this has been written with a negative sign, and this has been written with a positive sign. So in the next step, we will take the double derivatives of these terms. So what we get is, so this will be, I will show for the first term, that is I vector multiplied with, so when you take this derivative inside, so what do you get? Double derivative of a2, so dou square a2 by, here you have dou y and then dou x, minus next this and this, so dou square a1 by dou y square, because these two are same, and then this minus this and this. So what will happen here? Dou square a1 by dou z square, and then this and this. So it will be minus into minus will become plus dou square a3 by dou z dou x. So dou z dou x. So this is for the ith component. In a similar manner, we will do for the jth component and kth component as well. And after doing, what we get is, so this is what we get after doing so. Now if you see in the first term, we have here dou square a1 by dou y square, and dou square a1 by dou z square. So in order to make it cyclic, if we have dou square a1 by dou x square with a negative sign, it will be easy for us to combine the terms and write. For that reason, in the ith component, we are going to add and subtract dou square a1 by dou x square. So if we add, we have to subtract also. And what we will do, we will the one that is subtracted, that is with the negative term, we will combine with this, and the one that is added, we will combine with the other two terms. Similarly, what has to be added and subtracted for the jth component? If you see, you have dou square a2 by dou x square, dou square a2 by dou z square. So if you have dou square a2 by dou y square, it will be convenient. So this we have to subtract with along with these terms and add it to these two terms. So it can be combined in that manner. If you see in the kth component, here you have dou square a3 by dou x square minus dou square a3 by dou y square. So in that case, you have to add and subtract dou square a3 by what is not there. It is dou z square. So that can be subtracted from these two terms, and it can be added to these two terms and combined and written. For example, first I will show you for the ith component. So go through that very clearly. So first, in the ith component, so this will be equal to I vector multiplied with. So what I told you, we have to add and subtract dou square a1 by dou x square. So the term that I am going to add is along with these two terms. So here we have dou square a2, dou square a3. So what I am going to do, dou square a1 by dou x square. So this term is added to these two terms. So plus dou square a2 by dou y dou x plus dou square a3 by dou z dou x. So this term I have added. Now I need to subtract. So the subtracted term I'm going to combine with this. So minus of, so since all three will be having a negative sign, I can take that negative sign common. And what is that term? Dou square a1 by dou x square. So minus dou square a1 by dou x square. It has to be combined with these two terms. And since this minus I have written in common outside the bracket, I can write plus dou square a1 by dou y square, and then also plus dou square a1 by dou z square. So that is what we have here. Can you see that? Yes, so this one. So dou square, dou z square. So I have combined it in this manner. In a similar manner, we can do for jth component. That is, dou square a2 by dou y square has to be added to these two terms. So let me add and write and show you. So plus j vector multiplied with, so first I will write that is dou square a2 by dou y square, the adding part. So first I will write this term because it is a1 here. So dou square a1 by dou x dou y. Then I will add this. So plus dou square a2 by dou y square. And then I'm writing this term. So plus dou square a3 by dou z dou y. Now I'm going to subtract this term. So minus of, how we will subtract? First we will write this component, that is dou square a2 by dou x square, then this term. So plus dou, so that it will be cyclic. So dou square a2 by dou y square plus this term I will write now, this term. So dou square a2 by dou z square. So jth component is over. In the same way we have to write for this kth component. So plus k vector multiplied with now these terms. So this has to be added to these two terms as I told you before. So first I have a1 over here. So let me write that dou square a1 by dou x dou z. Then I am writing this term. So plus dou squared a2 by dou y dou z. Then the added term. So plus dou square a3 by dou z square. That is what we are adding. And minus of. Now here we have this term I am writing. So dou square a3 by dou x square plus this term dou square a3 by dou y square, and the term that we subtracted, since we have taken the minus out, we can write plus dou square a3 by dou z square. It may seem to be complicated, but actually it's not. If you go through it very patiently, definitely you will understand it. So kindly look into it very patiently. Now we have obtained all the three terms and we have combined and we have written in this manner. Now if you see in the ith component, in these three terms, dou by dou x is in common. And in these three terms, a1 is in common. So we can take whatever is in common. So first I will write I vector. So you see here, so this is equal to I vector multiplied with. So first in these three terms I am having dou by dou x in common. So I am writing that dou by dou x. So what will be left inside the bracket? So one of the dou by dou x has gone. So we will be having dou a1 by dou x. Okay, because here it is dou square a1 by dou x square. Dou by dou x have been taken common. So we will be having dou a1 by dou x. And here also dou by dou x is taken common. And so we will have dou a2 by dou y in this term. And then in this term, dou a3 by dou z will be there, since dou x have been taken in common. So this is over. Minus, as I told you, in these terms a1 is in common. So we can write it as dou square by dou x square plus dou square by dou y square plus dou squared by dou z square. And since a1 is in common, we can write it in this manner. In a similar way, let's do for j vector and k vector. In j vector, what is common? Dou by dou y is common. So plus j vector, in a similar manner, dou by dou y is in common. And if you see in the first term, what is left out? Dou a1 by dou x. So dou a1 by dou x. And in the second term, dou a2 by dou y. So plus dou a2 by dou y. Plus in the third term, dou a3 by dou z. So dou a3 by dou z. So after taking dou by dou y in common, this is what we obtain. And minus of, here what is in common in these terms? A2, if you see. A2 is in common in everything. And so this can be written as dou square by dou x square plus dou squared by dou y square plus dou squared by dou z square. And what is in common? A2 bracket. So this is over. Now we will write for the kth component. So plus k vector multiplied with, now if you see in these three terms, dou by dou z is in common. So dou by dou z. So that we can write, and within the bracket what you will get? Dou a1 by dou x first. So dou a1 by dou x plus dou a2 by dou y. So dou a2 by dou y plus here dou a3 by dou z. So this is done. Minus what is common in these three terms, if you see, it is a3. So here also you have a3, a3 and a3, and so this can be written as dou squared by dou x square plus dou squared by dou y square plus dou squared by dou z square of a3. So this also we have obtained. So this is the ith component, this is the jth component, and this is the kth component. So you could see the ith component, jth component, and kth component. Now what we shall do? Now if you see in all the ith, jth, and kth component, these three are same quantity. So they can be taken out first in these three terms. So what you will be having? I vector dou by dou x, j vector dou by dou y, and k vector dou by dou z of these three. So first we shall write that. So as I told you, I have taken this one term in common from all the three terms, that is this term, first term, second term, and third term. And after taking common, I have combined these three and I have written in a similar manner. Now this is done. These three terms are done. In a similar manner, here also, this and this are in common. So this will be taken in common, and what we will have? A1 I vector, and then you will be having a2 j vector and a3 k vector. So these three we will take in common and we can rewrite. Also we have the negative sign in common in all the three terms, and this can be rewritten as minus of, so we get minus of dou square by dou x square plus dou square by dou y square plus dou square by dou z square. And in common we will be having a1 I vector plus a2 j vector plus a3 k vector. So this is what we get. So what is this actually? If you remember, in vector differentiation, it is the gradient. So gradient of, and what is this? It is the divergence. So divergence of a vector minus, and this is the Laplacian, that is nebula square. And what is this? It is the a vector. So this is a vector. Therefore this is the gradient, this is the divergence of a vector, this is the Laplacian, and this is a vector, and on substitution of all that we get the right hand side that we are required to prove. So this is the right hand side that we are required to prove. So hence we have proved the required result. Therefore we have proved that the curl of a vector is equal to gradient of divergence of a vector minus Laplacian of a vector. So hence we have proved the result. This is a very significant question in the examination point of view, and it has appeared in various previous year question papers also. So kindly go through it patiently, step by step. Definitely, you will understand this better. Thank you.